This is R.D. Sharma solution, class 11, chapter 30, derivatives, exercises 30.2. This is question number 2, and we have to solve it using the differentiation by first principle. So first one is e raised minus x. So that will be fx plus h minus fx by h. So wherever we have x, put x plus h first. Then the original, that is e to the power x, has to be put in here and then divide by h. Every time you have to do this only. And then we'll try to eliminate the h, or we'll try to make some value, some expression that we already know what is the result if we apply the limit. So fx is given as e raised minus x, negative x. So what we will do? Fx plus h, that is put x as x plus h first, minus x plus h, minus fx, that is e raised minus x, and division by h. And this will be limit h tends to 0. So I'm not writing that right now. Just e raised minus x plus h can be written as c. If e m plus n is there, you can write e m dot e n. The power, raised power adds. So e minus x you can take common now. E raised h minus h minus h. So you have a h here. Put minus 1 and multiply numerator also by minus 1 because we have introduced this minus 1. Now this you see e raised theta minus 1 by theta. So limit h tends to 0. E raised minus x is constant. So you can just take it outside. So e ki power theta or y or anything minus 1 by that y or theta or something. And that thing tends to 0 will be 1. So this is going to be 1. Only minus 1 remains and e raised minus x will remain. Now d by dx, fx, and fx is e raised 3x. So all the questions of this part, that is the second part of exercise 30.2, are e raised power. So e raised 3x, so just put x as x plus h. So e raised 3x plus h minus e raised, that is 3x, and divided by h. Limit h tending to 0. So this becomes e raised 3x plus 3h. So e raised 3x dot e raised 3h minus e raised 3x, and e raised 3x you can take common. E raised 3h minus 1 will come. H is already there in the below. 3 multiply numerator denominator. And now limit h tends to 0. This becomes e raised x minus 1 by x. So that will be e raised theta minus theta, e raised minus theta minus 1 by theta. Limit theta tends to 0 is 1. So only 3e raised 3x will remain. Third one is e raised ax plus b. So fx plus h, fx is e raised ax plus b. So first you have to do x as x plus h, means put x as x plus h. A, this is x plus h, and plus b also, I'll just include it just now. And e raised ax plus b by h. So e raised ax plus h plus b minus e raised ax plus b by h, and limit h tending to 0. Limit h tending to 0. What do you get? E raised, this is ax plus ah plus b, and minus, oh, this also you can write it as ax plus b plus ah. Okay. You can write this like this only, just to make it equivalent to the other one, that is e raised ax plus b. Now this can be written as e raised ax plus b dot e raised ah minus e raised ax plus b. So e raised ax plus b you can take common, e raised ax plus b, and what is inside? E raised ah minus 1 by h. So h is there, you need to include this a also. Limit h tending to 0. So a multiply a here also, just to make it ah. Now this from here to here is going to be 1, you know already. So e raised ax plus b into a is the final answer here. Fourth one, x e raised x is the fx. So first principle, put x as x plus h, e raised x plus h, minus this is x e raised x, and divided by h and limit h tends to 0. This is the first principle I have applied. So numerator you can write this as x plus h, and this can be changed to ex dot e raise h, powers add up if these bases are same, minus x ex. So if you want to take common, you can take common, or rather you can do one thing, you can first multiply and take common. So both ways it is possible. Let us see if I do this e raise x. So what I'm going to get inside? Am I going to get something inside worth x plus h e raise h minus x? So I'm not getting that much help from doing this. So better is to multiply this x plus h with ex eh. Multiply this now. So what do you get? X e raise h plus h e raise x e raise h minus x e raise x, and this is divided by h. I'm doing h later. First take these two, first and third one. So I'm taking now x ex from here, first and third. So x e raise x, what is going to be inside? E raise h minus 1, and the other one is h e raise x e raise h. Now h was already there, so you can divide now. Divide by h. Now apply the limit. When you apply the limit, h gets cancelled here. First of all, limit e raise h minus 1 by h. This is going to be 1. This is going to be 1. We have already seen this. So only x e raise x will remain. This x e raise x will remain. This is 1. Now e raise x, now e raise h. Now put h as 0. Anything to the power 0 will always be 1. Anything to be power 0 is 1. So we have 1 here. So now here you can take ex common from here and x plus 1. This is the final answer. Well, you can put it like this only. Okay. Now fifth one. This is x. This is x square. See, it's x square e raise x. So almost same thing we have to do. Same thing we have to do. So what we will do here is, I'll do it with the first principle, x plus h whole square e raise x plus h. Wherever x is there, put x plus h. Minus, this is x square e raise x square e raise x, and divided by h. And just multiply this. Divided by h I'll use later. This is x square plus h square plus 2xh, and this is e raise x dot e raise h, and multiply this, x square e raise x e h plus h square e raise x e raise h, and 2xh h e raise x e raise h minus x square e raise x. Okay, so are we able to take something common? Yes. E raise h minus 1 by h will form. How? See, this one x square e raise x e raise h and x square e x. This x square e, last one, first and last, you can take from this x square e raise x common. So x square e raise x common, and then you have e raise h here and here minus 1, and you can always divide by h because h was already there. First principle, h is always in the denominator. Now what all else is remaining? This h square e raise x e raise h, and you have h here, so you can cancel h. Then you have 2x h e x e raise x e raise h. So this is 1. When you apply the limit, x square e x will remain. Here h and h gets cancelled, but since h is there, limit h tends to 0, so this is whole going to be 0. H gets cancelled, 2x e raise x e raise h. So 2x e raise x, and e raise h was already there, and when you put h as 0, e raise 0 is 1. As I suggested you earlier, anything to the power 0 is 1. So e raise power 0 is 1. So it is going to be only 2x e raise x. Okay, ex, x square plus 2x, this is going to be the answer. I am taking ex outside. Okay. Now the next question is sixth one. Fx is given as e raise x raised to ex square plus 1. So ex square plus 1, so just make it ex plus h whole square plus 1 minus e raise x square plus 1, fx plus h minus fx, and divided by h. So divided by h I'll use later. First let us solve this. This is limit h tends to 0 by h. So let us take this one. So what we'll do, we'll just open it. A plus b whole square. So x square plus h square plus 2xh. Then you have plus 1 already here. And minus ex square plus 1. So you need ex square plus 1 from the first term. So just separate them. We need ex square plus 1. So x square plus 1 will take ex square plus 1. And then the remaining is h square plus 2hx. So you can have e square, e to the power h square plus 2xh. So now you can take h common from here also, second term. So h plus 2x will remain. So why I am doing this, you'll just know. So e raise, this is e raise h plus 2x. Okay. Now we have got e raise x square plus 1 which we wanted, minus e x square plus 1. So we'll take this e raise x square plus 1 common from here. So e raise x square plus 1 common, and inside this we have e raise h into h plus 2x, and then we have minus 1 because we have already taken this outside, and divided by h. Okay. So if you see here, this is h plus 2x. So we need h plus 2x in the denominator because we need to apply the formula or the theorem we had. So h plus 2x in the numerator, denominator we have to multiply. Now if you see this e raise theta minus 1 by theta, limit theta tends to 0 form, it has come. So this is theta, e raise theta minus 1 by theta, limit theta tends to 0 equals 1. So this becomes 1. Okay. So e raise x square plus 1 is remaining, and this will remain. What about this is going to be 1, and this is going to be h, apply h as 0, only 2x will remain. 2x into e raise x square plus 1, this will come. Now 7th, e raise under root 2x. E raise under root 2x, fx is given as e raise under root 2x. So we will apply the first principle, e raise under root 2x plus h minus e raise under root, this I am writing, minus e raise under root 2x by h. Limit h tends to 0 divided by h. You can assume that I have put in. Let us go with the first one. First means the numerator. So what is the approach here? We have h in the denominator, so we have to use it. So we cannot defer it for the last, but we need to use it here only. I am going to take e raised under root 2x common from here. E raised under root 2x. And whatever is coming in the denominator will make it as the denominator. So we will do what? There is h in the denominator. So h is here. Now what we can do here is h, and we need 2x plus this 2x plus h in the numerator. So 2 multiply, 2 divide. I am adding 2x and subtracting 2x now. So that I can get 2x plus h, 2x plus 2h. We need this. 2x plus h, that is 2x plus 2h. We need this. That is why we made this h such that we have this 2x plus 2h. Okay. Now from where it has come and why it is important? Still the whole work is not done because it is still under root. So we will take under root and make it as a square. And this 2x also make under root and square so that it equates or it is seen like what it is above. So a square minus b square, it is formula. A is under root 2x plus 2h. B is under root 2x. So a square minus b square is what? A minus b, a plus b. A minus b, a plus b. So you can write this as 2x plus 2h minus under root 2x and under root 2x plus 2h. Under root 2x plus 2h. Please see here, a square minus b square I am writing. So 2 is already there. E raised under root 2x plus 2h under root here, and then we have minus e raised under root 2x, and this divided by, now I am writing a minus b, a plus b. This is under root 2x plus h, 2x plus 2h, minus under root 2x, and then we have this as plus, under root 2x plus 2h, plus under root 2x, plus under root 2x. So a minus b is plus b for a squared minus b squared. Now we'll deal the numerator in such a way so that we get under root 2x plus 2h minus under root 2x. How do we do this? We can take e raised under root 2x outside, as I suggested you earlier. E raised under root 2x. So now I am showing it here. E raised under root 2x. So this will be 1 because you have already taken it count. What this will be? E raised under root 2x plus 2h divided by e raised under root 2h, 2x. Because we have taken this constant common. Now if this goes up, you know x to the power a by x to the power b becomes x to the power a minus b. Same thing we are going to do. E raised to h, 2x. I am saying h again. So it is under root 2x. Under root 2x plus 2h minus under root 2x. And then you have minus 1 also. So this you have got. And this is what we have in the denominator as well. So 2 is already there. 2 is already there. Now let us write this as e raised under root 2x. And then this one. E raised 2x plus 2h minus under root 2x. We are writing it like this. 2x plus 2h minus under root 2x. And this is there. And this I am taking with this one. Under root 2x plus 2h minus under root 2x. So you have under root. One more thing is remaining. Minus 1 is also there. Okay. So minus 1 is also there. Let me just put it here. And then this one and the other term I am taking, the denominator other time we'll take later. So this is under root 2x plus 2h minus under root 2x. Under root 2x plus 2h minus under root 2x, this whole. So what do you get? E raised theta minus 1 by theta form. We have replaced this. Now this is done. This is 1 by. This will deal later. I'll just tell you what we have to do here. First let us see this. 2 e raised under root 2x. And this is e raised theta minus 1 by theta. Same thing. We can assume it to be e raised theta minus 1 by theta or e raised y minus 1 by y. Okay, equals 1. So this is going to be 1. This whole is going to be 1. 2 dot e raised under root 2x, and this is going to be 1. And what about this under root? I'll take it later. I told you. Now just apply the limit. H is 0. 2h is 0. Under root 2x and under root 2x will come. That is 2 under root 2x will come. 2 under root 2x. 2 gets cancelled. You have e raised under root 2x divided by under root 2x. This is the final answer. Now the 8th one. See, 8th and 9th, they are almost similar. It was similar to the 7th one. So I'll show it here only. So we have ax. This is fx plus h minus fx by h. So wherever x is there, just put x plus h. So ax plus ah plus b will come. And this whole will remain here, fx. Now what you will do? You have to make this h. Similar to what we have done in the previous question. So h I am writing it as h. So you have ax plus ah plus b. So you just add this. A add here, multiply here. And then assume it to be k. So I am just putting it like k. Just not to write it again. So ax plus ah plus b. Ax you have to add, so subtract also. And ah you have, then b also is there, so you add and subtract b. So that it looks like what we have in the numerator. So now we have this term. Now since we have under root, we cannot just put it like this. It's under root. Now we'll take e raised under root ax plus b common. Similar to e under root 2x which we have just taken in the previous question. So what will there? E under root ax plus b when we take outside, it will be e under root ax plus ah plus b minus under root ax plus b, and 1 will remain here, minus 1. Okay. So e under root ax plus ah plus b when we take e under root ax plus b common, so this will be the term. Now still it is not coming because it is the denominator we have ax plus ah plus b, but we need under root. So you take under root and make it square. A square minus B square. Now A minus B, A plus B, just put it here. This is A and B. Assume it to be A and B. A square minus B square. So A minus B, A plus B. Now this one and this one. This one and this one. And this is again becoming e raised theta minus 1 by theta. See, this one, this with this one, and one with the other one. A was already there. E under root ax plus b was already there. Then you have this e, this term, whole term, divided by this same term, minus 1. So e की power x minus 1 by x form. So limit h tends to 0. This is going to be 1. Same as previous question. Here 1 by, now limit h tends to 0. This is 0. So ax plus b, under root ax plus b twice. This is under root ax plus b, under root ax plus b because h is 0 we are putting. So we have 1 by 2 under root ax plus b. So this is already there. E under root ax plus b and divided by 2 under root ax plus b. If you understood this, this will not be a problem. And the next question which is coming also will not be a problem. Only there log a will come. I'll just show you. Okay, this is here we have a raised under root x. It is not e raised, it's a raised under root x. Fx is given as a raised under root x. Okay. So what we are going to do here is fx plus h minus fx by h. So a raised under root x plus h minus a under root x by h. Now you can first of all make this h a under root x first let us do, and a under root x I am taking common. So here a under root x plus h, I'll just show you here. A under root x plus h minus a by under root x, a raised under root x, a under root x we are taking common. This will be a under root x plus h by a under root x minus 1. This goes up because a under root x, this goes up, and with the subtraction sign, power gets subtracted. A under root x plus h minus under root x minus 1. And then we have h. So how to write this h? This is x plus h minus x you can read. H is there, so add x and subtract x. It will be x plus h minus x. This one. Okay. So this x plus h minus x, we can take the root and square it, so that it equates to what we have in the numerator. So under root x plus h whole square minus under root x square. This is a square minus b square formula. A minus b, a plus b, you can just expand it. A square minus b square is a minus b, a plus b. This is a raised this whole. So this is say x or theta. A raised x minus 1 by x. So limit h tends to 0, or you can x tends to 0 or theta tends to 0, whichever way you want. This is log a. So this whole will become log a. So this whole will be log a. Base is e. A under root x was already there. What about this one? You put h as 0. Apply limit also here. H is 0. So you have under root x under root x. That is 2 under root x it will come. So 2 under root x will come. So final will be a under root x log a by 2 under root x. Final answer is this. Again, if you understood the previous two, you will be able to understand this one also. Now we have 10th as 3 raised x square. Fx is 3 raised x square. So if you remember, this question we have already done a question like this, e raised x square plus 1. The 6th question, the first question we started just now. Okay, 6th question. So same thing we are going to do like this. If you want, you can just refer to it also, but I'm going to show you here only. Wherever x is there, put x plus h. So 3 raised x plus h whole square, this is fx plus h, minus fx. So 3 raised x square by h. So x plus h whole square is a square plus b square plus 2ab, so h square plus h square plus 2xh. Now 3x square you can just take common. So when you take 3x square common, I'll just show you here. So when you take 3x square common, you have x square if you take common. Here 1 will remain, minus 1. And from here 3x square plus 2sh plus h square divided by 3x square will come. xh plus h square divided by 3x square. X square goes up. 3x square plus 2xh plus h square minus x square. X square gets cancelled. So you have 3 raised 2xh plus h square. So you can take h common. H plus 2x will come. So you have here 3 raised h and h plus 2x. So 3 raised h and h plus 2x you need in the denominator as well. So what you have in the denominator? This 3 raised x square will be in the numerator. Now we have h here. So you have to have a h plus 2x. So multiply h plus 2x here, and you have to multiply h plus 2x here also. So this whole, just assume it to be a. So a raised x minus 1 by x. What this will be if x tends to 0? This is going to be log a base e. This is going to be log 3. Now apply the limit. H tends to 0. So it will be log, this is a. Log base e is 3. 3x square was already there. Now coming to the h plus 2x which we have included by ourselves. H is 0. H plus 2x is there. H is 0. So only 2x will remain. Now 2x you can bring to the front. This is 2x into 3 raised x square and log 3. This is the final answer. Okay. Now this is question number 3 and we have around 9 subparts of this question 3. So it will take time. Better we will take it in the next discussion. So then thank you so much and take care of yourself.